the syllabus for your KVPY exam as well of 12th standard, and we are going to revise it through formulas. So keep your notebooks ready because it's going to be a very interesting session, and it's also going to be rigorous on your brains. So keep your minds open, keep your notebooks open, and get ready for the session with me, Shreyas, your master teacher for physics at Vedantu, and welcome all the new students to this very special English medium channel for all the aspiring students who want to crack the JEE examination or KVPY examination or board examination. So welcome to this new channel for all the new students out here. And guys, I have been training kids for quite some time, and I know what to do in the last day and just before the examination. So that's why we have made this very special session for all of you, so that we can quickly glance through all the formulas, and in case you have missed some formulas, probably this will enter your head. And they always say when somebody tells you or recites all the formulas to you, then it is said that you most likely will remember that formula more than you reciting that formula to yourself. So gear up, stick till the end, and I'm pretty sure you will at least attribute one question to this channel because we have revised all the formulas. And if you still want to get in touch with me, you can contact me on Shreyas_Vedantu. That's my Instagram handle, and you can tag me in memes and any other post that you would love to. Alright, and before we begin, show all your energy through your likes. Please do that because it's free. Second thing which is free is hitting the subscribe button out there. Go hit that, smash that subscribe button in case you have not done it yet, and show your support, because only when you hit the subscribe button you will be benefited with the amazing, awesome videos that we keep creating for you guys. And do not forget to bring in your friends, share the joy of learning, because sharing is caring and caring is also learning. All right, so welcome. Hello Achut, Prakriti, Yalni, Aishwarya, Atharv, Albert, Preetam, Pearl, Mrinalini, welcome everyone. So guys, are you ready? Are you nervous? Are you excited? Are you sad? Are you prepared? Are you not prepared? Are you happy? Are you thrilled? How are you guys? Let me know in the chat box because I can read your chats. Hello Sneha, hello Geeta, hello, welcome Dhruv, hello Atharv, hello Krishna, Nirupam, welcome Aditi, welcome everyone. And in case guys you have missed any of these classes, this was the week schedule. We had completed 11th formulas also on Monday. So do check this lecture out in case you want to revise the 11th formulas. And any other special sessions you would love to attend, please check it out in our playlist in our past videos. By the way, we have almost completed 11th and 12th portions almost on this channel, right? Some topics which are remaining will be completed in the next few weeks, but understand you can always clear your concepts on this channel no matter which topic you want to. And we are anyways going to solve previous year questions etc. in the next couple of weeks before the run up to your final mains examination. So this channel is for all 11th, 12th as well as 13th standard students, that is the dropper students out here. All right, nervous, excited, says Pearl. Prakriti is excited. Arvinanta Kumar is excited. Hello Samiksha, hello Geeta, okay. Somebody's from their mom's ID. Hello Nadwa. Welcome. Preetam is nervous. Okay, don't worry guys. So guys, one thing you need to promise yourself, stick till the end. Do not worry about the outcome. Do not get scared. If you see some formula which you have never seen before, the aim is to at least make sure these formulas stick into your head, so that tomorrow when you are going to write the KVPY exam, all right, you will probably remember this lecture and try and remember all these formulas. So let's get started. First, we are going to do optics, then we are going to go to electromagnetism, then waves, modern physics, and so many other things. So let's get started with optics first, because recently it was done on this channel. So with regards to mirror, there are some important things. Number one, the height of the image is always the height of the object. That means the magnification is always 1. It's neither diminished nor magnified. Then image distance is also image, or I can say the image distance is also the object distance. All right, so or how far you are from the mirror, the image is also that much deeper inside. The image is laterally inverted. So if you are a right-handed person, the image of you in the mirror is a person who can write using his left hand. Understand that. That's the meaning of lateral inversion. Then another important thing, the image velocity is always equal to the object velocity. So the image velocity is equal to the object velocity magnitude wise. That means if you run towards the mirror with 5 meters per second, your image will also run towards you with a velocity of 5 meters per second. So understand, this is also very important. If there is a mirror and if you run with a speed of 5, the image also runs with a speed of 5. And if you run like this with a speed of 7, then image will run with a speed of 7 like this. All right, remember these things. And another important thing, if the mirror runs towards you with a speed of, let's say, 6, and you are at rest, then the image will run with double the velocity, that is 2 into 6. Keep this in mind. If mirror is at rest, then these velocities are equal. If object is at rest, mirror is moving, then it is twice the velocity. Next important stuff. If you have a mirror and there is a ray which is falling onto it and it is getting reflected over here. This is a reflected ray first time. Now you tilt the mirror. Okay, you tilt the mirror like this and you have tilted it by theta angle. You will see the reflected ray next time will be also tilted, and this change is always 2 times of theta. So if you tilt the mirror by theta, the reflected ray tilts by 2 theta. That is something which you should keep in mind. Okay, these are some important pointers. Next up over here is, if you have a mirror and if I draw a normal, and this is the angle of incidence, this is the angle of reflection, we know both of them are equal. The next thing up is, the ray wanted to go here, so it has got deflected, so that angle of deflection is always 180 minus 2i. All right, so this is also very important. 180 minus 2i is the angle of deflection. And another important property is, if you have two mirrors at an angle, then if a ray hits here and gets deflected over here, the total deflection, very important, it does not depend on angle of incidence, it only depends on the angles between the mirrors. It only depends on the angle between the mirrors, not on the angle of incidence. It comes out to be 360 minus 2 theta after using geometry. So 360 minus 2 theta, that is the formula which you should remember. Another important thing which you should know is that whenever you have a problem on mirror, all right, you can always use this trick. Whatever is there in front of the mirror, just replicate it behind the mirror and forget the mirror. So if there is something in the mirror, in front of the mirror, forget the mirror, replicate it behind the mirror, forgetting the mirror. Now solve the problem normally, and in the end, collapse that entire geometry, that figure, back to the original value. Okay, just collapse it back, just fold it back in the end before giving the final answer. That's a trick which you can use, that is called as opening up method for mirrors, or reflecting it as it is. Okay, I hope this is very, very clear. Yes. So Pearl, no, you're not allowed to carry anything. I think you would have attended the lecture just before this, so you're not allowed to carry anything as such. So yes, this is for KVPY SA as well, because there are some 12th standard topics related to 10th standard which are also there. But yes, the problems won't be so advanced. Basic problems of 12th standard can come in SA. I hope this is clear. Okay, cool. Let's get going to the next concept. Concave mirror and convex mirror. Remember the rules in your NCERT. Redraw all the diagrams of concave and convex mirror for the objects at different positions, which you would have already drawn in 10th standard. You might think you know it or remember it, but trust me, it's better to draw it one last time. Remember the rules. The rules are very simple. If a ray goes parallel to the principal axis, after the reflection it passes through the focus. But for a convex mirror, after reflection, it appears to pass when extended behind through the focus. Okay, so that's how it is. And another important rule is that, if you draw a ray which passes through the pole, it gets reflected back symmetrically. So this is another important rule which can help you solve problems on mirrors or on convex mirror. So if there is a ray which is here on the pole, it gets reflected symmetrically below. Remember these rules which will help you form the image during the examination. So let's have a look at all the mirror formulas which are going to be helpful for you. Number one formula is radius of curvature and focal length. R is equal to 2f. That's one formula. R is the radius of curvature, f is the focal length. Next up, 1 by v plus 1 by u is equal to 1 by f. This is called as the mirror formula, standard. Then next up, power of the mirror. The power of the mirror is negative 1 by f. Be careful and remember one thing. If this f is in meters, okay, this power is in diopters. So for diopters, the focal length should not be in centimeters or millimeters. It should be in meters. Keep this in mind. Next up, the magnification, like this, that is height of the image upon height of the object, is minus v by u. This is the next formula that you should remember. Then width of the image gets magnified. So this kind of magnification, which is width of the image upon width of the object, also comes out to be the velocity of that. So velocity of that image, okay, upon velocity of that object which is there, right? That ratio comes out to be minus of v square by u square. This is the next important formula which you should know. Okay, write all these things down. Very, very important. Very, very important. This magnification, perpendicular magnification, transverse, normal magnification. This is the longitudinal magnification along the length of the principal axis. Alright, so check the question, which kind of magnification is asked. Usually they ask this magnification, but in certain problems they might ask you this. All the 11th standard or SA students, no need to remember this formula because they won't ask you. This is a formula which you learn in 12th standard. So don't worry about it. But other things are there in 11th standard. Alright, let's get going to the next concept. Are you guys writing these things down? I hope you are learning a lot today. And if you guys are learning a lot today, please do not forget to hit the subscribe button and hit the like button to show your support for this channel and to me. Alright, next up is refraction. So if this is the angle of incidence here, if this is the angle of refraction, if this is the speed of light in first medium, this is the speed of light in second medium, this medium has refractive index mu1, this medium has refractive index mu2. Also, the wavelength of light over here is lambda 1. If the wavelength of light over here is lambda 2, then what can I say? Sine of I, Snell's law, upon sine of R is 1 mu 2. The light goes from 1 to 2, which is also mu 2 by mu 1. Remember, 1 mu 2 is mu 2 by mu 1, which is also reciprocal of 2 mu 1, because 2 mu 1 will be mu 1 by mu 2. So they always go as a reciprocal, which is also speed of light in first medium upon speed of light in second medium. So this can be used for speed calculations. And remember, this is also lambda 1 by lambda 2 because C is F times of lambda and F is same. Frequency of light does not change, wavelength changes, speed changes. Remember this, very important. Preetham, don't worry, I'm also going to come to wave optics. Preetham, everything is going to be covered today. Don't worry about it, beta. Alright, so we're going to start with optics, electromagnetism, electromagnetic waves, then wave optics, and then modern physics and all of that. Do not worry. No, Abhilash, don't. No, you can't carry papers and all these things in the examination. You will be provided with everything, whatever is needed in the examination hall. I think you just need only your ID card and examination ticket and all those stuff. Just read through the instructions carefully. All right. Okay. Let's get going ahead. Shall we go ahead, everyone? Okay. So Satvik, I'm planning to conduct this session till 7 o'clock today. So yes, Get yourself prepared. This is going to be a long session because we have to revise all the formulas at least till 7 o'clock. I think the session is going to continue. Next up on your screen is basically, critical angle. So if you are in a dense medium and the light falls at one critical angle, then you will see that the refracted ray is at 90 degrees, and any angle after that, if it is incident, it gets reflected. So this is total internal reflection, and the formula for that, sine of the critical angle is 1 upon mu of the denser medium. So that's it. That is the formula which you should remember. Sine of I is 1 divided by mu. Keep this in mind, guys. Okay. Next up, if you are an observer, okay, if you are an observer in air and you look at an object over here, you will see the image being formed over here. So if this is the actual height, then the height of the image is slightly less, or the depth of the image is slightly less, it is shallower. And remember this formula, height of image or depth of image is height of the object divided by mu. So that is when the observer is in air. Just like when you see the bottom of the pool, it appears to be a little bit shallower. But if you are an observer, okay, in water, and you look at an object here at some height h0, the image appears to be over here. If this is hi, in that case hi is mu times of h0. Keep this in mind. Apparent depth, yes, very, very important formula. And that also leads us to, if you have a glass slab of thickness t and refractive index mu, and if you are an observer over here, then everything that you see over here, okay, anything that you see over here, okay, will get shifted. Yes, it will get shifted. If this is the object, this is the image. Everything will shift, and that shift is given by thickness into 1 minus 1 by mu. Keep this in mind. So the shift is thickness into 1 minus 1 by mu. Yes, I hope this is clear. Electrostats is important like other chapters, Preetham. All right? Cool. So, scare flare, don't worry, you will get to know how to log in into the KVPY exam tomorrow as soon as you enter the examination hall. Also on the KVPY website, there is a mock test. So just go and attempt the mock test. You will get all the instructions as well as the login screen, so that you know and you get an idea of how the login screen is going to look like tomorrow. Do not worry. Yes, only this is lateral shift and all that. Don't worry about that, Meghna. Those formulas are not important. Alright, even if it comes, solve it by sin I by sin R or geometrical optics. Nothing more than that. But this is a shift in depth. Alright. So whatever you observe through a glass slab, everything behind it will appear to be shifted. That's the formula that you should remember. Alright, let's get going ahead to the next formula. Curved surface refraction. If one side is having one refractive index, other side is having other refractive index, and the surface is not flat but curved and having a radius r, then the curved surface refraction formula is mu, come on guys, mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by radius of curvature. Use all your sign convention etc. while solving the problem. And magnification formula is also very important. Just like before, it is v by u, there is no minus and all that. Just that, keep in mind, with v there was mu2, right? So do exactly ulta, exactly reverse. So with v it will be mu1 and with u it will be mu2. So this is the formula which you should remember for magnification for a single curved surface. All right. Zubia, 11th formulas have been discussed already on Monday. So on this channel only you can just go to past videos and you can see all the 11th standard formulas. But also Zubia, remember 12th standard formulas will come for SA. Some of them, not the advanced ones, but the basic ones are going to come in SA as well. Okay, very good. So let's get going. Let's get going to the next question. Thank you, DJ Square 8. All right, let's talk about lenses. Now lens formulas again, let's get back. First is lens maker formula. So to find the focal length, you need to use this formula, mu minus 1, but this is refractive index of the lens with respect to the medium. Alright, very, very important. If it's placed in some other medium, this mu is going to change. So relative refractive index minus 1 upon 1 minus R1 minus 1 minus 1 by R2. R1 and R2 are the radii of curvature of this surface and that surface. If it's a plano-convex lens or plano-concave lens, then one of those R's will become infinity because it's a flat surface. So flat surface will have infinite radius of curvature and 1 by infinity will become 0. Keep this in mind. Then you get the lens formula, which is 1 by V minus 1 by U is 1 by F. This is another important formula. So this was the lens maker formula. This red one is lens maker formula. To make the lens, what is the formula? All right. And the power of the lens is 1 by F. And remember this, if the power is positive, then it is converging, and if it is negative, then it is diverging. All right. So this is how it works for power. Okay. So that's the formula for power. I hope you have written down all these things. Next up is magnification this way. Magnification is just V by U, which is image height by object height. Very important formula again. Recollect, the formulas are same, just that in mirrors you had plus here, here it becomes minus. In mirror you had minus here, here it becomes plus. So the change is only in the sign. Now you would have already guessed for the magnification this way, which is width of image upon width of object. All right, the formula is going to be just V square by U square without the negative sign. So keep this in mind. All right, so many formulas for all of you guys on your screens out there. Cool. Okay, let's get going. I hope this is clear. Okay. So Disha is asking, admit card should be black and white or colored. I would say please take a colored copy, that would be better. But just read through the instructions, just check if they have asked for colored specifically. But I am guessing that even black and white should be allowed. But just to confirm once, please check on the website. They would have mentioned it. But on a safer side, you can take a colored one. All right. So Tushar Swarkar, magnifications are of two types. One magnification is height wise. So height wise magnification, use this formula. If there is an object here, the image is wider like this, use this formula. Or if it is shorter like this along the principal axis, use this formula. Perpendicular to the principal axis, use this formula. Okay, Tushar, let's get going ahead to the next one. If you have lenses in contact, doesn't matter what kind of lenses, then the net power gets added. So it is P1 plus P2 plus P3. Therefore 1 upon F effective is 1 by F1 plus 1 by F2 plus 1 by F3. This is the formula when lenses are in combination. Keep this in mind. Okay, if the lenses are separated, okay, just imagine one lens is here, other lens is here, do not use this formula. Keep this in mind. Also, one more thing, if for example you are given a plano-convex lens and one side is silvered, that is, there is a mirror there, then this diagram is equivalent to this diagram, a double concave lens, because a mirror, what it does is basically reflects whatever is there in the front. So this is same as this, but keep in mind, wherever you get the image, again bring it back over here, because the mirror would eventually reflect everything. So when you opened up everything, so you have to again bring back also everything and close it off, because in the end you have to give the answer thinking that there is actually a mirror. All right, so that is another important stuff which you should know. All right, Jatin, like I said, the session will be till 7 o'clock. All right, let's get going ahead. Next formula for prism. Angle of prism over here and this R1 and R2 are related, and that is R1 plus R2. Another important formula for a prism. Next important formula, the total deviation. If the ray comes like this and finally emerges over there, then the total angle by which it deviated, this delta, is given by, come on guys, I'm pretty sure you would be remembering this formula, I1 plus I2 minus angle of prism. Very important. Okay, so keep these two formulas in mind. Now there is a graph as well which you should know, because for different angles you get different deltas, and the graph looks something like this, and the deviation is minimum when this angle I1 is equal to that angle of emergence I2. This I1 is equal to I2, then you will see the deviation is least, remember this, and when delta is minimum, remember I1 is equal to I2, R1 is equal to R2, and mu is equal to sine of A plus delta minimum divided by 2 divided by sine of A by 2. So this is the formula only when delta is minimum, not otherwise. Be careful. Okay, yes, I hope this is clear. So Santosh, no, you will not get a PDF of whatever I write. So that's why I said keep your notebooks out, because the PDF will only contain the blank screens. But you can always take a screenshot of whatever I have written down over here. You can always replay these sessions n number of times, nobody will stop you. Okay, so Shubh is asking, please discuss the sign conventions once. Yes, I'll tell you, Shubh, doesn't matter whether it is a lens or whether it is a mirror, always see where is the object. Let's say the object is here. Okay, the object is here. Take the pole, okay, take the pole as the origin, and this is your y-axis. Where will you take the positive x-axis? Think this way, the rays from the object will come like this, isn't it? So if they are going to go towards your right, this side is your positive x-axis. That's how it is. Now let's say the final refraction happens and the image is formed over here. Okay, all you need to look at is the coordinates. So the image is here, so the image distance will be positive because it is having a positive coordinate on the axis. The object distance will have negative coordinate because it is on the negative side. And if there is a focal point, since this is convex lens, focal point will be here. So this coordinate will be positive. So hence focal length is also positive. I hope this is clear, Shubh. Alright, so this is how this is done. Okay, look at the coordinates of the things. Next up, for thin prisms, okay, when the prism is thin, then, alright, thin prism means this is very small angle. Okay, so then the angle of deviation is A into mu minus 1. A is the angle of prism, mu is the refractive index. Then if there is white light which is entering the prism, it will spread into multiple colors. Alright, so there will be red over here, and maybe there will be blue over here like this, okay, violet over there, and green will be somewhere in between. Now this angle, okay, this angle which is there, it is called as delta omega. That is called as angle of dispersion. So that angle of dispersion, delta omega, is delta of violet minus delta of red. And lastly, dispersive power. The dispersive power is how much did it disperse, that is delta violet minus delta red, upon the deviation of the average color. The average color of red and violet is yellow, so it is deviation of yellow. So this entire thing gets divided with deviation of yellow. Keep this in mind. Alright, I hope this is clear. I hope this is clear. So Preetham, if prism is placed in water, obviously angle of emergence etc. will change, deviation etc. might be affected, so you can recalculate it depending based on Snell's law. Alright, cool. Let's get going. Acha, somebody was asking how to determine signs of radius of curvature in lens maker formula. Here it is. What you need to do, like I was telling you before, if this was the object, the rays are going like this, for example, and then you decided this is the y-axis, this is the x-axis, all right, and this is the origin. Now the ray is entering this surface first. So this is the first surface, this is the second surface. Okay, now what you need to do for this first surface, think about it, this surface center of curvature will be here, correct? Center of curvature of the first surface will be here, and for this surface the center of curvature will be here. Isn't that right? So hence C1 will be positive, C2 will be negative. That means R2 will be negative and R1 will be positive. That's how it is done. I hope this is clear. I hope this is clear. Yes, angular spread is same as delta omega Albert. All right. So let's get going with the next part. Now before I go ahead, let me also tell you, if you are interested to join the crash course and boost your performance, the link is available in the description box for you guys to join in with live interactive sessions, doubt solving, test series, mock tests, discussions, also special sessions with Anand and Pulkit sir, and also multiple teachers to help you, assist you with your doubts from morning till night. And all of this is available on a 30% sale which is going on right now. So instead of 10,000 rupees, you just pay 7,000 rupees and you are covered for your entire JEE Mains preparation till the end, and you can get all your doubts resolved along with test discussions and other live interactive sessions, and all the 11th and 12th portion will be covered. Use the coupon code SHCC21 to avail 30% off, because tomorrow is the last day of the offer. By the way, the crash course has just started 2 days back, so you can still get into that batch, else you will be a little bit late. All right, so go check out the details in the description box below. Let's get going to electrostatics and gravitation as well. Okay, Sunil, your JEE Advanced crash course will also begin very soon. Don't worry about it. Yes. Vaibhav Agarwal, SA revision has already been done on the same channel. There is a video for this in the same channel. Just go back into the playlist and you will see SA revision. All the formulas just like today we have conducted. Okay, do check it out. All right. So next up is electrostatics and gravitation. So guys, if you still have some more doubts, please feel free to contact me on my Instagram handle, which is Shreyas_Vedantu. Okay, or you can leave a comment. All right, leave a comment below the video. I will try and answer it today itself. Okay, so that's what you can do. Shreyas_Vedantu is my Instagram handle, or you can leave a comment below the video after this session is over, because we have a lot of formulas to cover today. So let's get going. First up, electrostatics. If you have two charges, okay, Q1, Q2, similarly over here in gravitation you have two masses M1 and M2, then these two might experience some force just like over here, and that force over here is 1 upon 4 pi epsilon Q1 Q2 divided by R square, and here that force is G M1 M2 divided by R square. Remember, 1 upon 4 pi epsilon naught is 9 into 10 to the power 9, and epsilon is actually epsilon naught into K. This is your dielectric constant. So if it is dipped in some medium, then permittivity will change. E naught is permittivity of free space or vacuum. So if dielectric constant is 4, epsilon will change and the force, net force will also change. But in gravity there is no such thing. So G is not dependent on any other medium or stuff like that. It's a universal constant. Keep this in mind. Okay, 6.67 into 10 to the power minus 11, and you should know all the values of the constants out there. Okay, let's get going. Let's get going. Now, after this, the next thing that you should know, is the potential energy formula. The potential energy is K, that is the total constant, which is 1 upon 4 pi epsilon naught. All right, Q1 Q2 divided by R, and here the formula is G with negative sign. Be careful, many people miss that. M1 M2 by R. Keep this in mind, guys. Keep this in mind. All right. Now, next up is potential and field. So, if you just have a single mass, then at a distance r, or a single charge for that matter, at a distance of r, the value of field is kq by r, and the value of potential, sorry, kq by r square, and the value of potential is kq by small r. Similarly, for gravitation, if you have a mass and you are at a distance r, the value of field due to gravity is gm by r, whereas the value of potential is minus gm by r. Keep this in mind, very, very important. So, if you have a positive charge, the field always goes radially outwards. This is how the field goes. Whereas if you have a negative charge, the field always comes radially inside. But for a mass, there is nothing like positive or negative, so it always comes towards the mass. The field lines are always towards it. And the next important thing is equipotential lines. This is how the equipotential lines look like for point masses or point charges. These are equipotential lines or surfaces. That means if you stand anywhere on this red line, the potential will be same. But each red line will have a different potential. So there will be definitely some potential difference between those equipotential lines. Keep this in mind. I hope this is clear. Yes, Smiley K. Yes, that will do. Okay. So, oh, I think I missed a square out here. Thank you for pointing it out. A square, yes. So, gravitational field is gm by r square, whereas potential is minus gm by r. So, keep all these things in mind, guys. Okay. I hope everybody's clear. I hope you guys are writing these things down. Are you guys making notes? Yes. I hope you guys are making notes and quickly practicing it somewhere on your rough sheet at least. Okay. Cool. Yes, very good, guys. And one thing you need to do, because I'm going to take so much of effort for all of you, one thing, actually 3 things. If you're not a member of this channel, first hit the subscribe button. Number 2, if you have not liked the video, first hit the like button. And number 3, please share this video with your friends. Make this family grow bigger, because your strength is going to be our support for conducting more such sessions out there, and that too for free. All right, next up, most important slide which is coming up out here. Here you have force, here you have field, or let's say you have potential energy. So potential energy, and here you have just potential, and here you have field. Field is E, force is F, potential energy is U, potential is V. Now let me show you how to relate all of them. Very, very important. If you want to find field from force, use this formula. It is limit F by, let's say, the charge. So charge tending to 0. This is how you find field from force. Force divided by the charge. That's it. 1 Q will go away. You will get the field. Okay. Same way, if you want to go from potential energy to potential, then all you need to do is potential is limit Q tends to 0, U divided by Q. That's how the formula works. Next up, if you go from field to force, all right, then all you need to do is force is charge into field. Okay. Same thing, if you go from potential to potential energy, then understand that extra potential energy that you will get will be Q into that potential difference. So change in potential energy is Q into change in potential difference. That is another important formula. Next, if you go from field to potential, okay, if you want to go from field to potential, let's see how do we do this. So all you need to do is integrate electric field with dr with a negative sign, you will get delta V. So delta V is integration of E dot dr. Same way, from force to potential energy, all you need to do is integrate force with respect to dr with a negative sign. What you get is delta U. Okay. Next, if you want to go from potential energy to force, very important formula. So minus du by dr is force. Remember this. You would have read this somewhere. And if you want to go from potential to field, same thing, minus dV by dr is equal to E. So keep all these things in mind. So depends, why not mass? So if you want to replace with mass, then replace with mass everywhere. So for electrostatics, use Q. Obviously for gravitation, guys, what will you do? Instead of charge, you will use, yes, mass. So this will not be called electric field, it will be called gravitational field. I hope this is clear. All right. I hope this is clear. Okay. Yes, let's get going to the next part. Okay, this is very important slide. Now, next slide up for you guys, and that is, field and potential due to various geometries. Very important geometries coming up. First up is a ring, and you are at a distance x, and this is radius r. So the formulas are similar, let me tell you. So at this point, okay, what will you get the field as? Okay, so the field is k q, all right, divided by r square plus x square whole raised to 3 by 2. Okay, now you can see dimensionally square, cube, square root. So effectively it is cube. Remember, field always has square of the length below. Correct? It only has the square of the length below. So dimensionally there must be one more dimension of the length, and that is x. Why is that so? Because when x is 0, field is also going to be 0. If you are at the center, the field will cancel out. That's how it is. And in gravitation, the field will be gmx divided by gmx divided by r square plus x square whole raised to 3 by 2. That's how it works. Potential wise, it is just kq divided by r square plus x square. It's not raised to 3 by 2 for potential. And same thing in gravity, it is minus gm, there is no thing over there, and divided by r square plus x square. Keep this in mind. This is for a ring, guys. Very important formula. Okay, cool. I hope this is clear. Yes, very good, Abdul. I can see you are answering very quickly. Very good, Princey out there. Very good. Praveen, very good. Yes, tomorrow exam is for everyone. Elakya, yes, it is. Albert, for all gravitation formulas, it's always going to be negative. Okay, only for electrostatics, the formulas are positive. Next up, shell. If you have a shell and radius r, then outside the field is as if it's a point charge. So it is just kq divided by r when r is more than r. And the potential is just, r square, my bad, kq divided by small r, okay, when you are outside. This is the value of potential or field when you are outside. It just behaves like a point mass. But, all right, so this is when you are outside. But when you are inside, okay, so when you are inside, then what happens? So when you are inside, then the electric field is 0 when r is less than r, and the potential is a constant value. It is kq by radius of the shell. Keep this in mind. Same formulas are valid for gravitation. Just put a minus sign, and instead of k put g, instead of q put mass. That's the only difference. Yes, that's how it is. Very important formula. Keep this in mind. Inside, the potential is constant, field is 0. Outside the shell, it behaves like a point charge or a point mass. Same rules apply for gravitation also. There is no difference. Now, next comes, you have a sphere, okay, and you are again outside, and then we are also going to go inside. So we're going to go in, and we're also going to stay out. But this time, the only difference is that it is a solid sphere. Okay, it's completely filled with charges, or it's completely filled with mass. So then what will be the difference? So it's a solid sphere. So when you're outside, things are very simple. When you're outside, electric field is kq by r square. Okay, when you are outside, potential is kq by r. There is no difference, like you can see. It behaves like a point charge. But when you are inside, things change. when you're inside, things change. The electric field will be KQ small r divided by r cube. Be careful. Okay, for gravity it will be Gm small r by r cube. That's the difference, Gm small r by r cube. And potential has one crazy formula. Remember this, K, Q, okay, something minus something divided by something cube, and that is r cube. And you have 2 over here, and you have 3r square minus r square. This is the formula. Again, r is less than r. So this is the crazy form which you must remember. Yes, so be careful, be careful. I hope this is clear, guys. Everybody has understood this. Very important formulas. Shall we go ahead? Shall we go ahead, guys? Yes, everybody up to speed. All the new timers out here, we are discussing all the formulas of 12th standard, and even this is useful for SA stream because there is some 12th standard portion which was taught in 10th, which is also going to be asked in SA stream. So it's going to be, this session is also going to be useful for all the students who are going to appear for the upcoming JEE Mains Advanced KVPY examination. All right, very good, very good, very good. So Dhruv, no, this sphere is not conducting if the charge is uniformly distributed. Remember, if a sphere is conducting, then all the charges will come out on the periphery and it will behave like a shell. So you can use the shell formulas for a conducting sphere, okay, for electric fields. Next up, okay, next up. Oh, I need to give you special formulas for gravity. So very, very important. Now, we are not talking about electrostatics out here. Oops, 1 second. Yeah. So I'm not talking about electrostatics. Okay, this is not for electrostatics. First up, okay, if this is the Earth and there is a satellite, okay, and this is height h, then you can say this total thing is r, which is r plus h. Then that satellite is going to have some speed and it is going to go in a orbit. It will have some time period, etc. So first up, velocity is root of gm by small r, and time period is 2 pi root small r cube by gm. This is the satellite formula. And next up is escape velocity, velocity of escape from the surface of a planet. That is root of 2 gm by r. Very, very important formula. Again, next formula, if you are on the surface, okay, if you are on the surface, then the gravity on the surface is gm by r square. But let's say you are at some height, then the gravity at that height is gm upon r plus h whole square. That's the difference. But if this height is small, okay, only in that special case, then this formula approximately comes out to be gravity on the surface 1 minus 2h by r. Please remember, this formula is only when height is very, very small. Otherwise, use this. That is, height is in few kilometers till few 100, 300 kilometers. This will work. More than that, go to this formula. This is the exact formula. Similarly, when you go inside the Earth at some depth, the gravity at some depth is given by g naught into 1 minus d by r. Notice these two formulas look similar. There is a 2 here, there is no 2 here. Second thing, this is an exact formula applicable for all the depths. In fact, when you put the value of d as r, that is, you are at the center of the Earth, r by r is 1, 1 minus 1 is 0, gravity will be 0, which is what you will predict. This is an exact formula. This is approximate only for this particular assumption. Keep this in mind. Okay, let's get going now. Yes, next up is Kepler's laws. Let's quickly see that. Okay, 1 second. Yeah, so your massive object is always going to be at the focus of an ellipse. This is the small object. This is always going to be an ellipse or a circle. And remember that massive object is going to be at one of the focus. Next up, if this is called as the perihelion, this is called as the aphelion. Okay, and remember the speed is maximum at the closest point and it is least when it is at the farthest point. Okay, this is second thing. And the angular momentum is constant. The angular momentum is constant, and the value of angular momentum can be I can write it as L by 2m is rate at which area is swept. This L is constant angular momentum, remember, and this dA by dt is rate of sweeping the area. Rate of sweeping the area. This is the next thing that you should know. Okay, cool. Let's get going to the next thing. Okay, so this is Kepler's laws, and the third law obviously everybody knows, time square is proportional to the cube of the radius. This is the next or the third law that you should remember. Okay, cool. Let's get going. All right. Next, let's see. Yep. You should know the fields due to different charges and masses. I'll just quickly glance through this. This is a dipole. So this is how the field looks due to a dipole. If the charges are similar, then they go away from each other. If you have a conductor, remember field inside the conductor is 0. Correct? The field inside the conductor is 0, and also the field lines are always perpendicular to the surface of a conductor. Keep this in mind. For gravity, remember field lines are always going to be towards the masses. They will never go away from the mass. And equipotential lines, the ones shown in green, are those lines where the potential is constant and they will always be perpendicular to the field lines. Not just for gravitation but even for electrostatics. So if one were to draw equipotential lines over here, then I would still continue drawing like this. These will be perpendicular. These are equipotential surfaces. Okay, remember this. And always remember, field goes from high potential, high voltage, to always low voltage. High potential to low potential. That's another important property that you must know. Okay, and for infinitely charged conductors, the field lines are almost parallel to each other, and that's why I will call it as uniform field. Uniform field is when the field is constant and the lines are parallel to each other. So this can be achieved by using very large sheets which are charged. That's how this works. Keep all these things in mind. Okay, next up is magnetic field due to different conductors. You should know this. A wire carrying current, Orsted's experiment. Use right hand rule, you will get magnetic field's direction. A loop carrying current, again use right hand rule. If this is the direction of current, then the thumb will give you the direction of the magnetic field. You can see that thumb gives you the direction of magnetic field. Next up, solenoid. If the solenoid is carrying some current, move your fingers like this. The thumb gives you the direction of the magnetic field. Again, this is an electromagnet. And if you take this solenoid and bend it and connect those ends, it forms a toroid. So the coil is wound like this. So here the magnetic field lines were escaping out. Here it will not escape out. It will stay inside that particular conductor. Remember the formulas for solenoid. The magnetic field inside the solenoid is mu naught Ni. N is turns per unit length, and for a toroid, the magnetic field inside it is again mu naught total turns by 2 pi r into I. So what is this N? Total number of turns, and if I divide by 2 pi r, I'll get turns per unit length, because 2 pi r is the circumference, guys. I hope this is clear. Okay, this is important. Yes, very, very important. Yes. Okay, cool. Now what about these formulas? I'll be giving you all these formulas in a comparison chart. Okay, so let's have a look at all these formulas first of all. Now now before going to these geometries, first let's talk about dipole moment. Dipole moment is charge into length in electrostatics. Okay, this L is the length between the positive and the negative charge. Okay, this is the dipole moment. In magnetism, the symbol is capital M and it will be magnetic pole strength into the length. So this L is the distance between the north pole and the south pole. This small m stands for the pole strength. Remember, this is the pole strength of it. This is magnetic dipole moment. This is for bar magnets. But if you have an electromagnet, then the same m can be written down as number of turns into current into area of cross section. So if there is current, then there is magnetic dipole moment like this. There is a north pole and south pole formed this way. This is magnetic dipole moment of a coil carrying current. Now, once you know dipole strength, understand if you place a dipole in somebody's field, in external field, okay, in external field, there is a torque on the dipole and that torque is P cross E. Remember this. Same thing for magnetism, that torque on a magnet or an electromagnet is M cross E. Keep this in mind. Next up, the potential energy is minus P dot E. It's a dot product. And in magnetism, it is again minus M dot B. Keep this in mind. Okay, you can see the formulas are very, very similar. Yes. Now I know some of you are saying, sir, isn't it 2L? Well, no, it is not 2L. Guys, that's where you guys make a mistake. See, understand, why do you want to remember it as 2L? See, if there is a positive and a negative charge, if I tell you the total length is L, why do you want to write it as 2L? Why do you want to write half the length as L? It is confusing. Please do not do that. A lot of people make mistakes because of that. I have been teaching for almost a decade now. I know what is going to cause a mistake and what is not going to cause a mistake. So do not do it as 2L. L is that's why I said L is the total length between the poles or the positive and negative charges. I hope this is clear. I hope this is very clear. Next up here is, due to a dipole, what is the field? Very, very important formula. Okay. Now, the formulas are very similar, but let me just show this to you. This is a positive charge. This is a negative charge. Okay. And this is called as the axial point. And this is called as the equatorial point or the equatorial region. Okay. The same thing works even for magnetism, guys. So you will have an equator. And remember, you will have that bar magnet over here, north pole and south pole, and this will be obviously the axis of the magnet. This is how it is. Now, the general formula. Okay, see this, guys, very, very important. This is the direction of the dipole. Okay, this is the direction of the magnetic dipole. Okay, this is how the dipoles are oriented. Now, if you are standing at any distance, let's say R, at some distance R, okay, then there is some field over here and some potential over there. Same thing, if you are standing at some distance R, but this should be much, much larger than the length of that magnet. So that is basically called as a short dipole. Then what is the field and what is the potential at that point? Very interesting and simple formulas. The field is given by, how many of you know this formula? Let's see, how many of you know this formula? Come on, guys. So the field formula and potential formula is Kp root 3 cos square theta plus 1 divided by r cube. You can substitute whatever theta you want. So if you want axis, so on the axial position, theta is 0. Okay. On the equatorial position, theta value is 90 degrees. That's how it works. Okay, so keep this in mind. So you can use this as a general formula. I hope this is very, very clear. Okay, now Arun, hi, welcome. Thank you very much. Come on, let's get back. Okay, now let's get going. Potential formula. Potential formula is Kp cos theta divided by r square. Now, same thing works in magnetism, guys. There is no difference. Instead of K, you will have mu naught by 4 pi. Instead of P, you will have magnetic dipole, and you will have same thing and divided by, r cube over here. And same thing for magnetic potential as well. Again, mu naught by 4 pi m, and you will have cos theta divided by r square. So the formulas are same. That's why we are doing it together. Interesting? Okay, cool. Next up, okay, let's get going guys to the next thing which is going to come up on your screen. Let's revise everything. And guys, don't worry, anytime you feel that you missed a particular formula, do not get tensed. Don't worry, just concentrate what is going on right now on the board. You can always replay this session 100 times before your tomorrow's exam, and you can watch whatever part you missed or whatever part you had a doubt with, n number of times. Keep this in mind, okay? Don't worry. Okay, now next up, the formula for field due to a charged plate. Okay, so here you will have formula due to a sheet carrying current. So there are a lot of wires which are carrying current in it, and lambda is the amperes per meter. So it is carrying some lambda ampere per meter current, and here there is sigma, which is coulombs per meter squared density. Then the field lines will look like this, uniform, and this field, electric field, is sigma by 2 epsilon naught, whereas in magnetism the field lines look like this. Use your right hand thumb rule. The field lines will come like this. On this side it is there, on that side it is this side, and that magnetic field, very similar. Instead of sigma you have lambda, and because epsilon naught is below, mu naught will come on the top and by 2. Very similar formulas, you can see that. Geeta, the session has been already made for maths at 1 o'clock. Shimon sir has already conducted a session for maths, so don't worry, you can always check back and on the past videos. And in fact, I have also made a video for all the 11th standard students who are also preparing for essay. Monday I had conducted a session. Please watch the replay. But these sessions are also important because 12th standard questions may also come in the easier version. Okay, next up for a long wire. Okay, so we have a long wire. Okay, we have a long wire and it has lambda coulomb per meter. Okay, charge density. So there is lambda coulombs per meter on that wire. And here in magnetism, you have a wire which carries some current I. Now, here is the thing. You are at some distance r and that wire subtends some angle alpha and maybe beta. Same thing. This wire subtends some angle alpha and some angle beta, and you are at some distance r. Then, what is the value of field over here? So the value of field, okay, so that value of field that you get is, keep this in mind guys, very important formulas which are coming up on your screen. So lambda by 4 pi epsilon naught sine alpha plus sine beta. If it's an infinitely long wire, if it is infinite, okay, if infinite, then alpha is 90, even beta is 90. Because this angle and that angle will become 90. 1 and 1 will become 2, 2 will cancel with 4, and you will get lambda by 2 pi epsilon naught. Same thing over here in magnetism, you will get this as mu naught by 4 pi I divided by r and sine alpha plus sine beta. This is the formula for a finite wire. You can also make this formula for infinite wire by putting alpha and beta both as 90 degrees. Yes. Oh, R will also be there. Thank you so much. Yes, my bad. Yes, R will also be there. Thank you very much. Yes. I hope this is clear, guys. Everybody understanding this? Everybody clear? I hope these formulas are going to really help you tomorrow, and I'm pretty sure you will get at least 1 or more or even 5 questions correct because of today's session. Yes, you're going to remember all these things in flashback tomorrow, and you will probably tell me tomorrow, sir, we did well. Okay, next up, okay, energy density formula. Density of energy, which is in joules per meter cube for electricity, is half epsilon naught E square, but energy density in magnetism is, remember, epsilon is on the top, so mu naught will come below, and instead of electric field you will have magnetic field. So joules per meter cube, because of the field stores energy. This is the formula. Okay, let's get going now to the next set of formulas. Let me just have some water. My throat is running dry. Abdul, it is not needed electric field on the axis of a disk. Never there was a question on that, and even if that comes, they will ask you a very qualitative question than a quantitative question, or you will be asked something based on, you know, the density is different or is a function. So don't worry about it, Abdul. I know a lot of people give that formula, but it is not needed. Yes, Somesh, obviously it will be useful for NEET because the formulas are going to remain same physics wise. So don't worry about it, Somesh, it's for NEET as well. Alright, next up, current electricity. Current is charged by time, but if current is a function of time, then integrate that current as a function of time from 0 to t to find the charge which has flown. Next up, current density is current by area of cross section, and J is a vector quantity. It is J is a vector quantity, so current is actually J vector dot A vector. So if you take area over here, make sure that there is a dot over there. So that's how you should remember this formula. Next up, okay, resistance. Resistance is rho L by A. This is resistivity, depends on the material. This is the length, this is the area of cross section. More the length, more resistance, more the area, less the resistance. And the resistance also depends on temperature. So it is R naught into 1 plus alpha delta T. Alpha is the coefficient of, you know, thermal resistance. It will be given to you in the question, or you will be asked to find it out based on other pieces of information. These are some basic formulas which you must know. Then apart from this, yes, apart from this, there are some more formulas. Let me give it to you. Ohm's law. All right, Ohm's law, everybody knows the potential difference is current into resistance, but there is an equivalent Ohm's law also. Electric field inside a conductor. Yes, electrostatics has zero field, but in electrodynamics there is field. That is why the charges are moving in motion. That is, instead of current density, instead of resistance, resistivity. This is the formula to find electric field inside it. And lastly, current is NVIDIA graphics card, remember it, NVDEA. What is VD? It is the drift speed. E is the charge, which is 1.6 into 10 to the power minus 19. A is area, I is current. What is N? It's the free charge per unit volume. All right, that will be also given to you. So free electron charges per unit volume, that number will also be given to you. So this is used for calculating drift velocity. I hope this is clear. Sandhya Rani, I have already completed Formula 11th revision. Beta, please check in the past videos. I have conducted it on Monday. You will see the title Revision of Class 11th SA Formulas. Please check it out. All right. So all the 11th standard formulas have been done. All right. Don't worry, Sandhya. All right. Let's get going ahead. Next up. Okay. So power in a circuit is I squared R or V square by R. Okay. This is in watts. So basically, if the question is heat, then it will be I squared R into basically time. This will be in joules. Please keep this in mind. Okay. So power and heat developed across a resistor. Okay. Next up, equivalent RCL circuits. Very, very important. Now, remember one thing. Resistors and inductors behave exactly the same way. Okay, that is, when you find their equivalent, this is R1 plus R2 and this is L1 plus L2. Same thing when you have resistors in parallel, okay, or inductors in parallel. Okay, remember this is 1 by L1 plus 1 by L2. Here it is, sorry, my bad, ulta likh diya. Okay, let me just write it down again. 1 by R1 plus 1 by R2. And this is 1 by L1 plus 1 by L2. This is how it works for resistors and inductors. But for capacitors, it's exactly opposite. When you combine it into one single capacitor, when they are in series, it is 1 by C1 plus 1 by C2. And when the capacitors are in parallel, keep this in mind, it is C1 plus C2. You should know this. Very, very important. Okay. Okay. Yes, Hema, I have completed EMI and you can check it out in the playlist. It is already there. Okay. Yes, yes, yes. Thank you, Sriram. Yes. All right. Now, next up, very, very important, which is coming. Okay. I hope this is clear, everyone. Okay. Now, equivalent EMF, very, very important. Formula again coming up on your screen. If there are multiple batteries with some internal resistance, E1, R1, E2, R2, you can convert it into one single battery and one single EMF. Okay. So let's see what is that formula. So that EMF is just E1 plus E2 and that equivalent resistance is just R1 plus R2. Why did I put plus minus? There is a small trick over here. If all the batteries are aligned together, then everything will be plus, 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 plus. But one battery is this side, other battery is that side. So it can be plus or minus. But for resistance, it is always plus because current flows this way or that way, the resistance will be the same. So that formula has plus minus only in EMF. Keep this in mind. So many batteries can be combined into one single battery. Similarly, if you have multiple batteries in parallel like this, okay, you can combine it into one single battery and that EMF is again E1 by R1 plus minus E2 by R2 divided by 1 by R1 by 1 by R2. Notice plus minus is only on the top, not below. Keep this in mind. And the equivalent resistance, 1 by equivalent resistance is 1 by R1 plus 1 by R2. So you can combine both these batteries into one single battery with internal resistance using this formula. Okay, I hope this is clear. No, Narsimha, it's not there. Okay. Yes, mechanics was covered in the 11th standard revision. So all those people who want mechanics, fluid statics, because all the 12th standard students are going to need that, my request, sincere request is please watch the 11th standard video. I have taught as if it's a SX session. So all the 11th standard, mechanics, rotation, center of mass, fluids, SHM, waves, everything has been covered in the 11th standard session. All right. Akansha Agarwal, yes, I took your name. Come on, let's get going. Yes, I hope all the Josh is high. Guys, I hope you are not tired because at least I am not tired. Are you guys tired? Yes or no? Let me know. Okay, so next up. These tricks are very important. Disguised form, I have talked about it. There will be circuits which look very difficult, but they will be actually very simple. There will be very simple circuits like either series or parallel. All right, this circuit comes out to be like a parallel one. Very important trick. Second trick, Wheatstone's bridge. If this resistor upon this resistor is this resistor upon that resistor, even if there is a donkey in between, forget that donkey because that will be of no use. No current will flow between C and D. I have taught you this trick. Please watch this in case you want to see some application problems. Infinite ladder. Many resistors in one after the other in infinite series or parallel combination. How to solve that problem? Please watch the current electricity playlist. All these questions have been covered. And also connection removal method. My God, why do I look like I'm just about to slap someone or I've slapped someone? All right, anyways. So yeah, there you have how do you remove this particular wire. I've talked about it. These tricks will help you solve problems. Next up. Thank you, Sriram. Thank you, Sriram, so much. All right, that's the whole aim of this lecture. I want you to get some confidence, guys. Let's get going. Voltmeter and ammeter. Okay, so remember a normal galvanometer, the deflection is proportional to the current in the galvanometer. Now in a voltmeter, okay, in a voltmeter, you have some device across which you want to measure the voltage. So there is a galvanometer with very high resistance. Okay, this is very high resistance and it is placed in parallel. In ammeter, okay, in ammeter, what you do, you have that galvanometer, you put a shunt resistance. This resistance is very, very small, and your device through which you want to measure the current is in series. Ammeter has low resistance, voltmeter has very high resistance. Keep this in mind. All right. So, and what do you do to solve problems? Solve it like a usual resistor problem. The coil resistance will be given of the galvanometer. So replace that galvanometer with a resistance and replace this device with another resistance. Now, doesn't it look like a normal resistor problem? Solve it normally. There is no need to be scared of voltmeter and ammeter. If you still want to see it in detail, watch my playlist. You will get all the details over there. Cool. Next up, capacitors. Okay, so in capacitors, what are the formulas? Let's have a look. First, charge is C into V. Next, potential energy stored in the capacitor is half CV square, which is half Q square by C. Next, between the plates of a capacitor, there will be field. This field is given by, yes, a lot of people confuse with this formula many times. That field is Q by A epsilon naught. Be careful. Whereas the force between the plates, the force of attraction between the plates, all right, because there is positive and negative charge over here, that force is Q square by 2A epsilon naught. There is a 2 here, there is no 2 over here. Keep this in mind. This is that formula. Do not get confused. Next up, if you have a parallel plate capacitor, the capacitance is epsilon naught A dielectric constant by D. That's the formula. If you have a cylindrical capacitor, that capacitance is 2 pi epsilon naught height divided by log of bigger by smaller radius. And if you have a spherical capacitor, that capacitance is, and you can also put K over here if there is some dielectric medium, 4 pi epsilon naught K divided by 1 by A minus 1 by B. Bigger minus smaller term, you can keep it like that. Okay, these are the formulas which are important for, yes, capacitance. Sharif, take it and go. If they allow it, take it. If they don't allow, if they give you separate pen and paper, then use their pen and paper. You take it and go, right? As a safety measure, take a pencil, take a pen and go. But if they do not allow, just leave it outside. All right? Yes, you will get rough papers, etc. Obviously, rough papers, everything you will get. Okay, so let's get going to the next one. Okay, next formula for charging and discharging of a capacitor. Okay, same formulas are there for inductors also, but Q for charging, okay, is C E and 1 minus e to the power minus T by RC. This is the formula for charging. And Q for discharging, all right, is initial charge, and you have e to the power minus T by RC. Time constant is RC, and you should know those graphs for charging and discharging. So for charging, if it looks like this, all right, the final charge is C over here, and for discharging, it starts like this and goes like that. So that's how it is. You should know these graphs as well as time constant and all these formulas. Shubham, just check the instruction sheet. Also check Shimon sir's lecture, all right, whether he has told that you need Aadhaar card or no. Because today I was fully devoted to this session. I have not got time to check the instruction manual and all that stuff. Just check it once on the website. Please check it, okay? Okay, guys. Next up, yes, paramagnetic, ferromagnetic, diamagnetic material. This sheet is very important. Take a screenshot, all right, of this. Very, very important. What is susceptibility? What is relative permeability? How does it come? Is it permanent? Is it temporary? Which materials exhibit diamagnetic? Which materials exhibit para or ferro? Very, very important. Yes, Hema, I have completed the video on optics. In fact, yesterday I conducted marathon. So Hema, I would advise you to please check the playlist of our channel. All the videos, whatever are required, are there. Yes, and optics has been completed. Next up, the formulas in magnetic properties. Magnetizing field H is B naught by mu naught. Magnetic intensity of magnetization is B induced by mu naught. All right, that is also there, and it is also total magnetic moment per unit volume. Then remember, just like in electricity, if external field comes, there is induced field. In magnetism, if you pass the field from outside, there is an induced field. In diamagnetic, the field is opposite. In paramagnetic, the field is in the direction but small. In ferromagnetic, the field is very strong in the direction of external field. Keep this in mind. Okay. Susceptibility is this value I by H. Okay. Susceptibility is I by H, and permeability is B by H. All right. So it is B by H. Very important. And last formula up here. Okay. I think it's not showing for. Okay. Yes. Relative permeability is permeability of that medium upon permeability of free space. Okay. That's the relative permeability. And last formula over here. Relative permeability is 1 plus susceptibility. Keep these formulas in mind. Yes. Chetali, nobody can guess the cutoff for KVPY SX. It's very difficult to tell now, but try to score maximum. Don't worry about the cutoff scores right now, because if you think about the cutoff score, then you might get demotivated or you might get overconfident. Just put in your full strength is what I'm going to say. All right. Cool. Let's get going. Let's get going. Yes. Okay. Chalo. Let's get going to the next one. Electromagnetic induction, guys. Let's quickly do this. First, Faraday's law. Electric induced EMF is d phi by dt. That's one thing. Use Lenz's law. So Lenz's law will give you direction. How? Understand, induced current will produce magnetic field. Keep this in mind. Will produce magnetic field to oppose the change. It will always oppose the change. Remember this. It will always oppose the change. And motional EMF formula. Okay, motional EMF. So moving rod creating EMF. The EMF induced is L vector dot V cross B. This is the formula. Keep this in mind. L vector dot V cross B. This is very important. It's a scalar triple product. Also remember, forces on a charge. Force on a charge is Q V cross B. This is the force on a charge due to magnetic field. It's very useful in this chapter. You will see many problems on this, as well as force on a current carrying wire, I L cross B, the Lorentz force. Very, very important formulas. I L cross B, Q V cross B. Okay, cool. Let's get going to the next one out here. All right, cool. And there we go. Maxwell's equation. So all the Gauss law, Ampere's law on one slide. So you might be wondering, so where did you keep your Gauss law and Ampere's law and stuff? Well, here it comes. Gauss's law, cyclic integral, electric field dot area vector is the charge inside the closed surface by epsilon naught. Keep this in mind. Similarly, Ampere's law, B vector dot dl. You keep traveling across a loop and come back to the same point. That's why the cyclic integral is the current enclosed inside. Okay, into mu naught. Hold on a second. My bad. Okay, so this will be mu naught into current enclosed. Okay, next up, cyclic integral B dot dA is always going to be 0. Very important theorem. See, E dot dA is this. B dot dA is 0. Keep this in mind. And cyclic integral electric field dot dl vector is not 0. Be careful. This actually is nothing but the voltage difference, and that, or basically I can say the induced EMF, and that will be always minus d phi by dt. Keep this in mind. So this is always induced EMF across a loop, and that will be minus d phi by dt. Keep this in mind. I hope this is clear. I hope this is clear. Well, let's get going. Let's get going. Yes. Okay. Will there be formula based question? Yes, there will be. Thank you, Akansha. Yes. Very good, Shubham. For Rohit, this is an English channel. I would be rather happy if you could talk in English out here. Is this syllabus for 11th and 12th different? Yes, Hema, it's different. Is there any new theorems that you should study? Well, don't sit and study now new theorems. Just look at the problems. All right. So that's how it is. I would say, Atharv, you should solve at least 70% of the problems, total problems. That would be a safe score. Okay. Okay, let's get going to the next one. AC generation. Okay, so the EMF generated by a generator is B A omega n. Born, remember born, sine omega t. Okay, so B is magnetic field in which the coil is rotating, A is area of the coil, omega is the angular speed, n is the number of turns. That's it. So that is the EMF which will be generated when a coil rotates, and this EMF will be like this, the one which is shown over here. This would be your maximum EMF, that is this one will be E max, or sometimes it is called as E naught. Now the RMS value, all right, will be E naught by root 2. Remember this, very important formulas out there. Keep this in mind, guys. Okay, cool. Yes. And the average value is always 0, because as much as positive, that much negative is there. So the total will cancel out and you will have 0 average. Keep this in mind. Okay, all these are important formulas. Let's going to the next one. All right, phasor diagrams. I know many of you face some difficulties. Let's come back to this. This inductor, capacitor and resistor behave like resistors when AC current flows through it. The effective resistance of an inductor is reactance. It is called omega L. Sorry, it will be omega L. The effective resistance of a capacitor in an AC circuit is XC, and it is 1 by omega C. Keep this in mind. But the current flowing through all of them will be the same because they are in series. Therefore, the voltage across an inductor will be current into the resistance of the inductor or capacitor. Remember that. So it will be XL. All right. So voltage across inductor will be current into resistance of that inductor, which is XL. Ohm's law, guys. And voltage across capacitor will be obviously current into resistance of the capacitance, and voltage across resistor will be just I into R. Alright, so these are the formulas for VR, VL and VC. Now for phasor diagrams, what is the trick? The trick is very simple, I'll tell you. Always draw current over here. Okay, always draw current over here. Now resistance and current, whatever is there, will be always in the same phase. So the voltage across the resistor will be in phase with the current, and amongst L and C, who is going to come on the top or below? Very simple thing. Love is above all. Just remember this phrase. Love is above all, so VL. So love is above all. Just remember this phase, and VL will be on the top and VC will be below. This is 90 degrees, 90 degrees. Now by vector addition, yes, by vector addition of VL, VR and VC, you can find the net voltage, which is over here. So this E is actually vector sum of VL, VR and VC. Keep this in mind. And that will make some angle phi. This is called as the phase angle between voltage and current. So that is your phase angle. And the power, all right, the power in the circuit is Vrms into Irms into cos phi. This cos phi is called as power factor. Keep this in mind. This is called as a power factor. Keep this in mind. Rohit, we are revising everything, so that's what we are doing. All right. Yes. So I've just written love is above all, so please pay attention to what I'm saying. So because I don't have so much of space out here right now. So this is power is equal to Vrms Irms cos phi, and that is power factor. I hope this is clear now. Yes. Next up over here is, you can also draw the same diagram for resistance. So this will be resistance this will be XL, love is above all, remember, and this will be XC, and if you take the vector sum, okay, you will get Z, and Z is nothing but impedance, and remember one thing, Z value is root of R square plus, first subtract these two, so XL minus XC whole square. Alright, so that's how it works, and it has the same angle. There's no difference. You can also draw this triangle out here. I hope this is clear. Okay, cool. Let's get going to the next set. Transformers. Yes, turns ratio N1 by N2 is V1 by V2, which is I2 by I1. Keep this in mind. Turns ratio. Turns on primary upon turns on secondary is voltage on primary upon voltage on secondary, but inversely related to the current in secondary and current in the primary. Keep this in mind. This is for transformer. Okay. Next up, electromagnetic waves. Okay. First formula that you should know. The electric field or magnetic field will be E naught or B naught sine or cos kx plus or minus omega t. This is the electromagnetic wave equation. K is 2 pi by lambda, omega is 2 pi f. Keep this in mind. Alright, now you can take this lambda and f, wavelength and frequency, to get speed of light, which is lambda into f is also root of 1 upon root of mu naught epsilon naught, which is also E by B, which is also, if you divide E by B, you will get it as E naught by B naught. Very, very important. And the direction of C, the velocity of light, is always parallel to the direction of E vector cross B vector. This is another important formula. Anurag, that is not possible in this video because I have clearly mentioned this is a formula discussion video. So if you want applications better, I have discussed all the applications of the formulas of whatever chapters I have conducted in the playlist. So please watch the playlist for JEE Mains to see how these formulas are exactly applied. And I'll be doing, PYQ sessions and other sessions where we'll be discussing problem solving, etc. Don't worry about it. Yes, don't worry. Yes, Anurag, obviously nobody can watch everything right now. So that is something which you should have planned better long time back, 1 month, 2 months back. Okay, I have to cover this much. So, you need to plan it in advance. So obviously in the last day, you cannot have everything where we solve also and we discuss formulas also. I hope you understand that. All right, let's get going to the next one. Okay, intensity. Intensity is mu naught. Intensity, yes, of the wave is E naught B naught by 2 mu naught. So that is the intensity of that. And the pressure due to light falling on something is I by C if the light gets absorbed. Yes, if the light gets absorbed, this is the pressure falling on it, and it is 2 times of this if it gets reflected, which makes sense because then the pressure will be exactly twice of that. Keep this in mind. Okay, so these are some important formulas that you must know. Then for polarization, understand this another important formula. If this is the intensity of unpolarized light, okay, which is passing through a polarizer, this intensity is always the intensity of unpolarized light divided by 2. So if the light is unpolarized, there are multiple angles, only half the intensity will pass through the polarizer. Now, if there is a polarizer and if, let's say, the light's plane is making some angle, okay, light's plane is making some angle theta with the polarizer. If this is the plane of the light which is entering inside of intensity I, the light which comes outside of it, gets polarized, but that intensity is the previous intensity cos square theta, where theta is the angle between the polarizer and the incident light's plane. So keep this in mind. Okay, I hope this is Clear? Okay, cool. Let's get going to the next one. Okay, cool. And oh, I forgot one thing, Brewster's law over there. So remember this Brewster's law. So when light falls on a surface, it gets refracted and reflected when it is perpendicular. Okay, this is the incident light. When it is perpendicular, then remember one thing, this light is polarized. Yes, this light is polarized, and you can say this is the angle of incidence. Okay, that will be also same, obviously. So that tan of I is equal to mu. Very, very important. This is called as Brewster's law. That unpolarized light becomes polarized if reflected at this angle. Very important. So last minute important chapters, whatever I am discussing over here, electromagnetism, gravitation, mechanics, that will be very important. Okay, next up, due to multiple sources, what is the intensity? Intensity for a point source is inversely proportional to the square of the radius. Keep this in mind. As you move away from a point source, the intensity reduces as inversely related to the square of the distance. For a cylindrical source like this lampshade, it is inversely proportional to R. Keep this in mind. And for a planar source, intensity is constant. This will be useful for solving problems. Okay, cool. Next up, constructive destructive interference. Everybody knows. Please watch again. I have taught you this in the waves part as well, but still I'll tell you, if the waves crest and crest merge, it will be constructive. The crest and trough merge, it will be destructive. But anything else, if there is a path difference like the one shown over here, then you can first find phase difference using this formula, 2 pi by lambda into delta x. From this you will get the resultant amplitude, which will be a1 square plus a2 square plus 2 a1 a2 cos del phi, but everything under the root. Keep this in mind. This is how it works, but for intensity of the resultant, the formula is slightly different. It is I1 plus I2 plus 2 root I1, 2 root I1 I2 cos del phi. That's the formula for intensity. Keep this in mind. Okay, yes. Now, next up, diffraction of light. I'm going to give you all the important formulas which you should know. If it's a slit, very, very important. If it's a slit, okay, there is a slit of width d, okay, then the light gets diffracted. You will have maxima and minimas over there. Then remember this very important formula, guys. Yes, n lambda by d is equal to sine theta. This is your angular position of minimas. This is the angular position of minimas. So that theta will be this theta over here. Okay, so that is that theta, which will tell you at what angle are you going to get the minimas. This is for a slit. But for a hole of width d, all right, so for a hole like thing or an aperture, the formula is slightly different. The formula is 1.22 lambda by d is sine theta 1. This will only give you the first minima. You will not get problems for second minima or third minima. Only the first minima. Keep this in mind. Let me just drink the water before going ahead. Let's go ahead quickly. Sunil, the reason why we are conducting these sessions is because, you know, when somebody tells you these formulas, then it gets stuck in your head. When you discuss something with your friend, with your teacher, then it gets imprinted in your memory. So just by reading by yourself, that was my opening line. I think you missed it. So that's why you're asking this doubt. Yes, waves is also important. Yes, waves is also important, Kunal. But don't worry, Kunal, I'll be conducting special lectures for waves as well. Raja, any doubt that you have, please put it up in the comment section after the video. And also, if you want, you can ask me on Instagram. Yes, let's get going ahead. Okay, Young's double slit experiment, what are the important formulas? First, fringe width. All right, the fringe width formula is lambda d by small d. That's one formula. Second formula, all right, the path difference. the path difference for a normal setup is d sine theta. Keep this in mind. This is d sine theta, and if it is constructive, equate this path difference to n lambda, and if it is destructive, equate it to odd multiples of lambda by 2. Keep this in mind. Okay, so this is how it works. All right, next up, wave particle duality. We have come to modern physics. Come on guys, let's do this. Momentum of any, or I will say, the de Broglie wavelength of any particle having momentum is h by p. First formula. The moment, if the energy of a photon has to be calculated, then it is hf, which is also hc by lambda. But the energy of a physical particle, all right, actual particle, all right, that is always half mv square, which is I can also say this is momentum square by 2m. Please understand, energy of a photon is not equal to half mc square, because what is the mass of the photon? Nobody knows. All right, so you cannot write this formula for a photon, but only for a particle. Keep this in mind. So de Broglie wavelength and particles being discussed out here. Next up is photoelectric effect. Yes, remember when you power up, yes, two plates on which on one of the plates you are seeing light falling, and because of which electrons are coming out. All right, so you can stop those electrons by applying a reverse voltage, which is called as the stopping voltage or stopping potential. So the maximum kinetic energy, all right, so this is the max Ke of the electrons, will be electron charge into the stopping potential. This is one formula which you should keep in mind. Also remember, the frequency of the light matters to as to which photoelectric effect will occur or not occur. Photoelectric occurs only after a particular frequency, that is called as the critical frequency. So hf naught is called as the work function, and this is your minimum frequency. Remember, this is the minimum frequency. And the last thing over here is the actual photoelectric equation. If the energy of the incident light is hf, is the energy of the photons, a part of it will just go to remove the electrons, that is the work function, and the remaining part will be available as kinetic energy. So I can just say this is equal to K max. Yes, this is the main photoelectric equation. Keep this in mind. Yes, very, very important equations. So just quickly analyze the working of photoelectric effect. Light falls, energy, part of it goes in removing it, and the remaining goes in kinetic energy. So the kinetic energy can be stopped by reverse potential, and the minimum energy to remove it is work function, which is hf naught. Okay, next up, remember all the formulas from atomic structure. Please remember all the formulas from atomic structure. Some critical results I will give you. The angular momentum is nh by 2 pi. N is the quantum number. Next up, radius is proportional to n square by z. This is another important formula. Energy is proportional to z square by n square, and velocity is proportional. Come on guys, velocity is proportional to z by n. You must remember who is proportional to whom. This is very important. Angular momentum, radius, energy, and velocity. This is one thing. I hope you have written this down. Okay. Now, yes, we will try and conduct a discussion session for the solutions discussions very soon. Don't worry, we'll do that. And the wavelength, yes, very, very important guys. The wavelength formula, when transition occurs, when electron goes from high to low, low to high, etc., the wavelength of the photon which is emitted is given by Rydberg's constant z square 1 by n1 square minus 1 by n2 square. Rydberg's constant value is 1 point. Come on guys, what is it? 1.097 into 10 to the power 7. All right, so that is the value of Rydberg's constant. You should know this. Next up, X-rays. Okay, X-rays. Okay, so first of all, what happens in X-rays? Electrons are accelerated through a potential difference. So the electrons get energy, which is E into V, and that is the maximum kinetic energy of the electrons, right? Electrons kinetic energy, and that will be equal to, think about it, that will be equal to the hc by lambda minimum. This is very important. So in X-ray graph, if you recollect, there are two kinds of X-rays. One is characteristic, one is continuous. Continuous X-ray. This is lambda minimum. If they ask you lambda minimum, this is how you're going to find it out. Okay. These things, K alpha, K beta, which are characteristic X-rays, can be found using that formula. Okay, that formula 1 upon lambda is equal to Z, Rydberg's constant. You can use that formula to find, you know, the characteristic wavelength. Keep this in mind. Characteristic depends on the target material. This continuous waves, continuous X-rays only depend on the potential difference through which it has been accelerated. That's how it works. Keep this in mind. Nuclear physics ke last formulas coming up. Okay, first of all, remember, yes, atomic mass number is Z protons plus number of neutrons. Radius of nucleus is R naught a raised to 1 by 3. Very important. Density of nucleus is almost constant. This has already come in the examination. Very, very important. Okay, keep this in mind, guys. Okay, cool. Next up, the mass of proton is a roughly mass of neutron, and it is of the order of 10 to the power minus 27 kg. Keep this in mind. And mass of electron is of the order of 10 to the power minus 31 kg, and this is roughly of the order of 1 AMU, 1 atomic mass unit, roughly. Okay, cool. I hope this is clear. Next up, yes, radioactive decay formulas. Let's do this quickly. If there is some mass defect, then the energy can be found out using delta mc square. This is how much mass is lost or gained. This is mass defect. You can also use this additional formula 931 into delta m, but this will be in mega electron volt. So this formula also helps if you want to find the answer in mega electron volt. Keep this in mind. Okay, keep this in mind. Okay, then your radioactive decay formulas, rate of disintegration dN by dt, all right, is minus lambda into the sample material. This is your decay constant. This is the material which is present, and this is also called as the activity of that sample. And in general, n is initial sample e raised to minus lambda t. This is the formula to find the amount at any instant. Also, half-life is ln2 divided by lambda. So it is log of, if you want, log of 2 to the base e divided by your lambda. That's one thing. And average life, yes, average life, keep this in mind, is 1 by lambda. These are two different things. This is average life, this was half-life, two different things. Yes, modern will also carry weightage. And remember the values of log, e, log 10, log 3, log 4, squares of numbers, square roots of numbers, decimals of, you should also be able to remember the decimal values of 1 by root 3, 1 by root 2. All these things are important. Okay, keep this in mind. And I have given all the properties of alpha rays, beta rays, gamma rays in the session PDF. Please glance through it or take a screenshot of this. Yes, yes, remember this. Okay, and now what you should do from semiconductors. Now semiconductors is pure theoretical chapter. So what you should do, read through conduction gaps, okay, conduction and valence band gaps if you want to. I'll just tell you the important things in semiconductors which you should go through. This energy level diagrams for insulator, semiconductor, conductor. What is intrinsic and what is extrinsic p-type and n-type conductors? Just glance through it. Next is basically you see what happens to the energy diagram when you add a impurity, either a p-type or n-type. How does the energy level diagram shift? Just observe that it is there in H.C. Verma. If you want to read, actually read H.C. Verma, not NCERT. That's what I would say. And lastly, depletion zone is one thing you should learn. Depletion zone and the drift current and the diffusion current. Drift current and diffusion current. And you should also see that in forward bias, the diode behaves like a wire. And in the reverse bias, it does not behave like a wire. It behaves like an open switch. This is right now in forward bias. The previous one is in reverse bias. So it conducts electricity only in one direction. And the last thing over here is the current versus voltage graph. Please glance through this. This is how it is. Okay. I hope this is clear. If you want Siddhi, yes, you can ignore semiconductor, no problem. But that is provided your other topics are very strong. Yes, Pearl, I have learned all these formulas because I have been teaching for almost a decade. So guys, please glance through the crash course if you want to learn under teachers like me. This crash course is available at a very discounted rate. The entries will close very soon and you'll have to wait for the next batch, and this sale is the Republic Day sale. Okay, so a lot of benefits. Please go through all the benefits which is there in the link. I'm pretty sure you are smart enough to go through that. Today I will not consume so much of your time. And guys, this is our Telegram group. Please join it for getting all the official important updates regarding JEE, KVPY, etc. All the PDFs, all the summaries, formulas, everything is there on the Telegram group. All right. So last minute tip, Athar. Okay, I'll give my last minute tip. Yes, Akshay, I'll give my last minute tip. The last minute tip is, guys, remember right now, first tip. Please sleep well, okay? Sleep for minimum 8 hours, number one. Number two, only glance through those things right now. Now you would have realized what you know, what you don't know. So just glance through those formulas and just see some simple problems just to see how to apply it. But don't overburden yourself. Stay cool for now, okay? Whatever happens, happens. It's okay. This test is like your eye-opener before the JEE Mains. Keep this in mind, okay? So don't worry, guys. This test will make you feel or give you a sense of how the actual exam is going to be conducted. So don't worry so much. Even if you perform badly, it's okay. But give in your 100%, stay calm. Number three, when you are concentrating on a question, do not think about next or previous question. Number four, if you do not get a question, leave it immediately, go to the next and come back to it later on. Most often when you leave a question, after some time you will get that question. Do that. Number five, do not think about anything else in the exam, about anybody else. Just concentrate on the question and just make sure you have read the question carefully for words like not correct, incorrect, or which of the following is true, false, etc. Or maybe some denominator, numerator mistakes, decimal mistakes, power mistakes, plus minus mistakes. So stay with a cool mind. You will do it well. And believe me, you're going to remember everything what I said today, tomorrow. And that is why I discussed all the formulas today. So guys, still if you want to ask me anything, please feel free to drop me on Shreyas_Vedantu. That's my Instagram handle. And also you can leave comments below. You can also watch the previous videos. Please support our channel, subscribe. Please like this video and share this video with as many friends as possible. Thank you guys. All the best. I'll be waiting to hear from all of you tomorrow. Please drop in the comment or message me how your exam was tomorrow. All right. Stay focused, stay cool, stay calm. All the blessings from my side to all the minions, all the V enthusiasts out here who have been devoted for this channel. Thank you. Bye bye. Take care. Good night. All the best.